One. Good morning, afternoon, and evening, everyone. Thanks for starting your week with us at another Data Engineers Lunch 85, to be exact. This afternoon, we have a special guest speaker, Will, who'll be going over designing a modern data stack. The speakers for the hosts for this event are Raul and myself. If you're interested, please reach out to me. We are looking for speakers and sponsors. My email address is listed below. However you're interested in assisting, we like you as a speaker or a sponsor or even just a member. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome. And we expect respect to be given to all. Data Community DC is made up of a larger part of different groups, all surrounded around data. You can find out more about these groups at the links listed below. So what do we cover here on Data Engineers Lunch? If it's your first time here, we cover everything from the ingress to egress of data. We cover databases, ETL, data wrangling, all the tools and processes in the data engineering world. If it's your first time here, please leave your name, how you're working with the data in the comments, introduce yourself to everyone. We'll also ask that you add what you're trying to learn from these lunches, what you hope to learn from these lunches, and we'll take it from there. Group rules, as I mentioned earlier, be polite and courteous to everyone. If you have a question, ask it. We are trying to foster community here. There are no bad questions, and our speakers always want questions, but just, depending on the speaker, ask your questions when it's most convenient to the speaker. And obviously share what you know with us. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. We'd like to thank our program sponsors, our organizational sponsors, all listed below. And then 15-second announcements. Again, if you have any jobs, meetups, hackathons, conferences, classes, please leave them in the comments below along with a link, short description. And we are hiring here at Anant. If you're interested in any of these positions or if you'd like more information, please visit our website or contact me directly. A few events we have coming up. Obviously, we have our weekly Data Engineers Lunch on Mondays, our Cassandra lunches on Wednesdays. We do have some different lunches sprinkled in between outside of that. But I'd like to draw your attention to the Scylla DB Summit coming up in mid-February. That is online, but do register today. And then also our latest Cassandra runbook. This will only be available for today. If you haven't downloaded the 12th edition of our runbook, please download it. I'll leave a link in the comments below. A new edition will be coming out this week. So if you haven't already, please make sure you grab your free copy today. And with that, I'll turn it over to our speaker for this afternoon. Will, over to you.
Thank you so much. Good afternoon, everyone. I'm going to go ahead and share my screen. So that should be the slides visible now. So today I'm going to be talking about designing a modern data stack and some of the constraints, challenges, and processes that work well there. And my name is Will Angel. Up until 2 weeks ago, I was the Senior Technical Product Manager for Caribou Financial's data engineering team. So building out the data platform there at Caribou, some really cool stuff. Unfortunately, I was laid off, so I'm actually in the market for new data engineering or technical product manager roles. I'll talk more about that at the end. If folks have questions, feel free to put them in the live stream comments and chat as we go, and I will address them either as they come in or towards the end. So today I'm going to be talking about what a data stack is, talking a little bit about how you want to go through the design process for building these data stacks, these data solutions. I'm going to give a couple of design examples of both sort of generic as well as specific projects. I'm going to give a quick demo of one of those, my own personal data warehouse, and then talk a little bit about some of the limitations of the modern data stack. So let's jump into it. What is a data stack? So before we talk about data-specific software stacks, we should talk about regular software stacks. And the idea is that your the software that you're actually interested in, usually some software application, runs at the top of a stack of different pieces of software. So a couple of notable examples are the LAMP stack and the MERN stack. And there are a ton of other different software stacks that people talk about. One that we all may also be aware of in the data space is the ELK stack, Elastic, Logstash, and Kibana. But these two stacks, LAMP and MERN, they have powered a significant portion of the web over the last 30 years. So you've got, for the LAMP stack, Linux, on top of which you have Apache, like the original Apache server, and then you have your database, usually MySQL. These days, more MariaDB and Postgres is eating into that. And then you have your server-side scripting language, which conventionally has been PHP or Perl. And the idea is that these, again, form a stack on which your actual application runs. So for data, our data applications are it's all still just software running on a computer somewhere. So is there a meaningful distinction? And the answer is yes and no. So again, it's all just software running on computers somewhere. So a data stack is a software stack. However, there are some places where there are meaningful differences that we'll get into a little bit more. And part of that is that every vendor that it has some tool, some new cool data tool, wants to market their tool as a key part of the modern data stack. So data stack and the phrase modern data stack is partially just marketing, but there is also something real and interesting there that we're going to get onto. So what makes a data stack modern? And there are a couple of trends that have led to the development of the modern data stack and also characterized it. The big ones are modern cloud platforms, column store oriented databases, the cost of disk, and the proliferation of managed data tools. So on the right here, this is Google Trends. So this is Google's publicly available sort of search frequency and interest. And you can see that the red line here is Apache Hadoop, one of the original big data frameworks and tools. And then on the left is the blue is Amazon Redshift. And you'll note that Apache Hadoop, the big data explosion of the 2010s reached a peak and then has proceeded to lose out in search interest to Amazon Redshift. So that's really one of the big shifts that characterizes the modern data stack and modern data engineering is some of those really large self-managed frameworks like Hadoop have fallen out of favor compared to doing everything on the cloud. So there are sort of, based on those four trends, there are sort of two defining characteristics of the modern data stack. If you disagree, I think there are more, or that this is incorrect, I'd love to hear that in the chat. So the first trend, or the first defining characteristic, is that a modern data stack is cloud and SQL based. So usually at the heart of a modern data stack, you'll have a column store based cloud data warehouse as well, and that's going to be SQL based. So not necessarily as much Spark, not writing MapReduce jobs. It's going to be SQL on a cloud data warehouse. Usually, most people will also use some sort of file store or object store based data lake around that to either help with ingestion and egress patterns or to help manage cost, because in some cases it can be cheaper to store things on files or on the file storage. The second defining characteristic of a modern data stack is that it is modular. And usually that means you have managed SaaS tools for every individual component of the data lifecycle. So there are a lot of different tools that are really, really powerful and really, really good. And usually, if used right, actually incredibly affordable compared to building and running your own tools. So a modern data stack is cloud native, mostly oriented around a SQL data warehouse and is very modular with different components based on what your use cases are and what you need. So let's go a little bit deeper into cloud data warehouses and talk about why they're special and why this is worth talking about. So the great things about cloud data warehouses is that they're managed and they're very flexible. So for a cloud data warehouse, you can go and go to Google Cloud, go to Amazon Web Services, and give them a credit card and go over and spin up a Redshift or BigQuery cloud data warehouse. And it's pay as you go. There's very little maintenance required. You don't have to go and purchase hardware. You don't have to install things in a data center. So there, the ease of getting started is significantly lower than it used to be. There are still companies today that have on-premises Hadoop clusters, and those are really expensive to run. And if you get to the point where you outgrow a data center, that's really awkward because it turns out it takes time to build new data centers. So there's a lot to be said for the cloud and the flexibility that gives you. In many cases, these cloud data warehouses, rather basically all cases, these cloud data warehouses are fully managed, which means you don't have to spend as much effort actually managing the infrastructure. And so they're, depending on the situation, you can usually see pretty large savings by using a managed service, which allows a data team you're trying to run this modern data stack to operate much faster. And oftentimes with less specialized operational experience, which, if you're talking about like low-level networking, complex distributed systems and software engineering and site reliability engineering, that talent can become incredibly expensive to find. So effectively outsourcing that part of your hiring and infrastructure to Amazon or Google is a fairly compelling option financially. So one of those additional trends that I wanted to touch on was the cost of storage. So this is a chart from the 1950s to the mid-2010s of the cost of computer memory and storage in US dollars per megabyte. And as you can see, the trend, and this is logarithmic, so it has been decreasing exponentially for quite some time now. And this, especially this right half from the 1990s to the mid-2010s, shows you that the cost of computer storage, so memory hard disks, has fallen from, in the mid-90s, like a couple of dollars per megabyte to fractions of a penny per megabyte. So it's about on the magnitude of 100,000-fold decrease in storage costs per gigabyte since the mid-90s, which means that really the whole big data revolution is actually just cheap storage, just bigger hard drives. And this decrease in storage costs has also come in parallel with Moore's law in terms of the amount of processing power that modern computers have. So my cell phone here has more processing power and storage than a supercomputer from the mid-1980s. So what we have to work with today is, in this case, 6 orders of magnitude better than what Kimball was working with in the 70s and 80s and 90s for data warehousing. So we have a tremendous amount of extremely affordable storage and compute that really gives us a lot more flexibility and options for how much data we can process and how cheaply we can do it. So those are a couple of the big defining characteristics of the modern data stack. I'm going to talk a little bit about the design, or a design process, for how you can actually go about going from zero to a functioning data stack. So broadly speaking, It's the same as any other software development process where you figure out what you want to do, you create a plan to do it, you do it, and then you see if you did it. And this shows up all over the place in different sort of decision-making frameworks. You've got the OODA framework, observe, orient, decide, act, the PDCA framework, plan, do, check, act. And there's no hard rules about how long you can take, how fast you have to do the cycle, how big an iteration has to be. In my experience, the faster you get through these whole iterations, the quicker you will be to deliver actual value, and usually the less pain you'll have while doing it. But there are also some places where a lot of this stuff just takes time. But in short, yeah, you figure out what you want to do, what are some of the design constraints, create that plan to iterate, and then you actually develop your software solution. So first step is problem definition. If you want to build a software solution, a data solution, you have to identify the problem. And this usually takes some mix of requirements gathering, defining a software, like a vision for what the software, what the data stack is going to do, often user research and interviews, talking to the people who are going to use your software, who are actually going to derive value from the data. Turns out the Agile Manifesto has some wisdom to it in that talking to your customers is good. You may also want to do industry research to figure out what kind of similar problems other people have. And then usually, depending on the environment you're operating in, you also want documentation and more documentation ad nauseum, et cetera. So once you have that nauseating amount of documentation on what you're trying to do and how you're going to do it, you're going to expand and create a sort of iteration plan to go from that sort of problem statement to actually having a working system. And usually this is the part of the plan or the part of the process where you draw a bunch of diagrams and write a bunch of Jira tickets, work breakdown, doodle stuff on napkins at the bar with your coworkers, all that good stuff that goes into figuring out how to develop software. So once you've got a plan of varying degrees of fidelity, you can go ahead and execute the plan. So you're going to actually build the software, probably do more software development around your software development process, things like unit testing, automation, all the things that make it faster to develop software. For the modern data stack, one thing that's very notable here is that procurement can be a large portion of the actual time and effort for developing a modern data stack. So depending on which vendors you decide to go with, a lot of them have commercial, off-the-shelf tools that are fantastic and usually worth the money, but you may have to, depending on your context, actually go and work with your procurement people, work with your finance people, work with your legal people, if you need to have a enterprise contract in place. In many cases, if your company, if your organization is already on a major cloud provider, you can usually just get started through them very quickly. So the procurement part there is fairly fast, but it can be a notable part of execution is actually purchasing and then integrating other software. Two things that I think should be included in every good execution of a plan is actually testing the software, both like sort of broader systems integrations, does everything actually work, as well as technical tests, and then user testing and demos. Actually showing people what you're building is a great way to get feedback to build it better. And that sort of feeds into the second to last step in the process, which is evaluating whether you did it. So this is the part where you step back and take a look at all that nauseating documentation you put together at the start and see did we actually build the thing that we wanted to do? And is it actually solving the problems that we were hoping it would solve? So does it actually provide value? And again, this is an iterative process. So this is the part where it's helpful to formalize ideas for future improvements. So if there are new features you could add or that people talked about, wanting in demos. So if a client or a user says, wow, this data warehouse is so great, but wouldn't it be better if it was purple, or could do window functions better? That's a great place to note that down and put it into the next iteration plan. And again, I think one of the things that's important for actually doing agile development is to reflect on the development process and identify improvement opportunities. So not just improvement opportunities for the software, but also for the software development process. And the last step is to repeat the cycle. So again, it's an iterative process that you cannot actually escape from. You can slow it down so that each iteration cycle takes years, but it's usually better to test early and test often to make sure that you're delivering something useful. This is true with all software development, but I think it is especially true with data-intensive applications, because usually the value of these applications depends more so on user adoption than on the actual system itself. So if the people, end users aren't using the data, that's not going to deliver a lot of value. And so it can be very helpful to make sure that you're iterating quickly and testing this with end users so that they can actually see the software, and that can be part of the rollout and change management process of delivering a new data platform. And so really it's not so much development as it is gardening in terms of trying to cultivate a vibrant analytics ecosystem. So that is the sort of approximate data solution design process at a very high level. I'm going to see if we have any interesting comments in the chat right now. So got some interesting comments about like Apache Spark versus Hadoop usage and how that compares to like Redshift, and comment about SQL. It's interesting that it's still considered modern. And that's actually one of the really interesting trends I think we've seen over the last couple of years is, I'd say 5 to 10 years ago, there was a lot of competition, both with things like NoSQL databases. Everybody loves Mongo. And it really looked like Spark was in the process of taking a lot of data processing that had been happening directly in SQL databases. So I think that's an especially interesting one. And I think the modern industry has decided to standardize on SQL, though that's kind of a misnomer because each SQL dialect is slightly different and isn't just drop in and replace. And I know some of the major cloud providers, I believe Google and I think Amazon, have SQL translation tools that will allow you to translate different dialects of SQL into their local one. So BigQuery has that for sure. So yeah, SQL is good. Definitely has places where you can see the age, but overall is pretty functional. Yep. Great comment from Rahul. MongoDB is web scale. Yeah. One of the things that I will touch on a little bit later is a modern data stack doesn't necessarily mean ultra scalable or ultra robust. It can, and usually it gives you that option, but it doesn't have to be. So I'm going to get into the two data stack examples that I have. This one is going to be a sort of generic BI data stack. So if you asked me to design you a business intelligence data warehouse and visualization stack, this is probably about what I do. And you'd have a couple of different components. So business intelligence means we're primarily going to be dealing with relational data. So that means tables, spreadsheets, things that are nice and structured for us. Usually, it depends, but so core component is going to be a cloud data warehouse. You can't really go too wrong. These days, basically all of the large data warehouses have some type of serverless functionality. I'm a huge fan of Google BigQuery, but Redshift and Snowflake are also very solid. For ingestion, I recommend using a managed ETL tool. Fivetran and Stitch are two of the big players. I've used both. Personally, I have a slight preference for Stitch because Fivetran tends to get expensive depending on how you're using it. There are also open source or open core alternatives like Airbyte, and Stitch actually is an implementation of the open source Stinger or Singer like sort of ETL framework. So both of those are great options. For transformation, again, this is relational data in a data warehouse. So a SQL framework like dbt, data build tool, is quite good. There are a lot of places where you can just get away with using pure SQL. If you have multiple people working on the same data transformations, having a framework like dbt gets you consistency. And one of the really big things when it comes to data management is consistency. So things like prefixes, different transformation layers, the more people that you have working on a data stack and doing data governance and data management, the more that consistency becomes very important. So I'd say the more people you have, the more using a SQL framework like dbt becomes truly wise. And then for visualization, whatever business intelligence tool is most comfortable for your analysts is probably the best one to use. I'm a huge fan of Metabase, but Tableau, Looker, Power BI, they're all good. I may actually be giving a small presentation at the Power BI DC user group meetup later this week, which that's going to be back in person, so that should be fun. But again, lots of good options here. Yep, and we got a comment in the chat that dbt is cheap and good. Yep, dbt Core, the open source project, is open source and free, and dbt Cloud, they did recently raise the prices, but it is very competitive with standing up your own Airflow cluster and managing all of that yourself. So yeah, dbt, it's a good tool. So those are sort of the core components of a data stack in terms of where the data is actually moving through. But you're also going to want some auxiliary components around data observability, data cataloging, as well as systems observability. So for data observability, there are proprietary tools like Monte Carlo and Big Eye, as well as a bunch of other new players in the space, and some open source frameworks like Great Expectations for defining data tests. For data cataloging, tools like Castor and Elation. I'm a huge fan of Castor Data Catalog. They're a French company, super awesome, a really good tool for managing and documenting your data, which again, like SQL frameworks, like dbt, the more people you have working with some data, the more that management, that documentation, that cataloging becomes very valuable, because if people don't understand the data in front of them, they won't be able to use it correctly or effectively. So again, the more people you have using a data stack, the more that the management of it becomes important. So the last thing on this list is systems of observability. And here two classic examples are Elk Stack and Prometheus and Grafana. They're a data stack, a data platform. Data stack is a distributed system, usually with multiple third-party vendors. And if you're using a tool like Stitch or Matillion or Fivetran, it makes it super easy to get data from every SaaS tool that your company or organization may be using and put it into your data warehouse. And That means that there are the surface area for things that can break and the number of integrations that can go wrong is very large. If you have, say, 20 integrations and each integration has a 10, call it 20% chance of changing their API every year. Every 5 years they do a full refresh of their API. That means you're going to have numerous changing integrations every year. So that's one of the biggest arguments for the managed ETL connectors is their software engineers will usually be the ones maintaining your integrations effectively. That's not always a perfect abstraction. So you will run into situations where Stitch or Fivetran deprecate an API connector because the underlying API is going away and the new data is in a different format. So the core pipeline itself for actually ingesting the data will still run, but you'll have to change how you transform it because the format has changed. So sort of no matter what you do, you're going to suffer a little bit when it comes to data. But if you choose your context wisely, you can get away with a minimum amount of pain and suffering. Let's see, a couple of comments. Oh, yeah. Rahul's got a great point about Athena to answer the question of what's the advantage of dbt over Athena. And yeah, Athena is basically a SQL interface to just about any kinds of data that you want to throw at it, whereas dbt is actually a framework for writing and executing SQL transformations. So with Athena, you can query a CSV file in S3 or something in Redshift. It's very seamless. Whereas with dbt, you could take the data in Redshift and transform it into a different table within Redshift. So that's about that for a sort of generic modern data stack BI example. Though again, there are a lot of different ways where you'd want to tweak that for your specific context. Maybe you're on something like AWS GovCloud and you can't use Fivetran, so you would need to you need to host your own open source ETL framework. That happens. So the second design example that I have for today is talking about a personal data warehouse for myself. So at a sort of high level, I wanted to build a data warehouse for a lot of the various personal data that I have from various social networks and other tools. So things like connection details from LinkedIn, messages from Facebook, messages from Telegram, just sort of all of that data that we now have access to thanks to GDPR and CCPA. So if you go into any of your social networks, you can dig down into the privacy details and eventually find a way to export all of your data, which is pretty cool. So for this project, there are a couple of design constraints and sort of freeing design characteristics. So given that this is a personal project that's not intended to be production or enterprise grade, I'm primarily interested in it being low cost. I don't want to pay a lot of money for data storage. Low maintenance. I don't really want to spend a lot of time managing this. And it has to deal with a wide variety of data. Exporting things like Facebook means there's a lot of photos, lots of nested JSON, some documents. So a wide variety of data formats. Thankfully, however, there are some non-constraining characteristics. For example, low velocity. Most of these data sources that I'm interested in are manual exports only. So to the best of my knowledge, Facebook does not give you API access to bulk download your data and probably never will. And I know that historically, for ways to scrape that data, most of the major social networks, the ones that I'm interested in getting data from, are actively hostile to scrapers and will sort of constantly be changing how they actually structure their website to prevent automated access. So most of these larger data sources are going to be fairly infrequent, so low velocity. I don't realistically see myself going in and downloading, my LinkedIn messages on a, more than weekly basis. Realistically, probably more like monthly or quarterly or annually. So it's not a particularly high volume data source, or excuse me, it's not a particularly high velocity data source. Likewise, the volume is relatively low. Each of these sources is, a couple of 100 megabytes to a couple of gigabytes for full download. So that's nothing too heavy. And in terms of access patterns, it's going to be a pretty low user count. I think it's just going to be me for now in this personal data warehouse. So again, thinking about the 3 V's of data, variety, velocity, and volume, this is 1 out of 3. So the variety is going to be a little bit intense, but the actual velocity and volume are going to be low and easy to manage. So as far as approximate sort of high level design, over on the right here, the approximate plan is to load data into Google Cloud Storage as flat files as much as possible. So things like CSVs. Use Dataflow, which is Google Cloud's managed Apache Beam implementation, to load that data into the BigQuery data warehouse, and then use Looker Studio, which was previously Google Data Studio, for visualization. Though the nice thing about using a data warehouse like BigQuery is it's SQL, so once you have the connection credentials, I can query that from basically any SQL engine. So if I wanted to pull it up in Python, could do that. Likewise, bring it into a spreadsheet. So lots of options. So this is the sort of high level design, but going on a little bit to the actual implementation for different sources. One of the fun things about a modern data stack is usually the implementation is pragmatic. So again, that's too soon. For a couple of these social media and messaging services, the implementation is I manually go to the website and download the bulk export, and then upload it from my local computer to Google Cloud Storage. For a few other data sources that I'm interested in, like Google Analytics data from my website, there's an option to directly stream that into BigQuery. So that skips Google Cloud Storage and goes into BigQuery. And then I've got a couple of manually entered data that I'm putting into Google Forms right now, and those Google Forms put into Google Sheets. And I want those Google Sheets to be sending that data into BigQuery. So that's things like whenever I weigh myself on a scale, I put that into a little Google form that I made so I can keep track of that over time. When I finish a book, that goes in the list as well. And pragmatically, Google Data Studio is great, but there are also places where you really just can't beat a spreadsheet. So in addition to the BI tool of choice, I'll also be using things in Google Sheets. Professionally, this type of diagram gets incredibly complex. The previous data ecosystems that I've built and operated end up with usually tens or hundreds of specific connections just within the managed data tools, let alone all the rest of engineering and the complexity there. So at a certain point, again, we're talking about large distributed complex systems, oftentimes with, depending on how you're doing it, no true development environment. That is one of the downsides of the cloud. So things aren't always nice, but usually things are fine. So before I get to the conclusion, I'm going to go ahead and show you all a little bit of the stuff that I have in Google Cloud right now. So let me make this a little bit larger. So here we have a couple of the buckets that I have created. So we've got Facebook, LinkedIn, Telegram, Facebook, LinkedIn, Telegram. And for the buckets here, the organizational hierarchy is raw data and then staging data. So for LinkedIn, for example, I'm going to open this up. You can see that we have the raw data that was uploaded is a zip file. So a zip file isn't super useful. So for the staging, we have that done as just as the unpacked file. So we've got a bunch of different CSVs. So we can see this is my personal LinkedIn information. So you can see the certifications that I've got. I don't remember what those are. Connections, contacts, education, email addresses. Looks like every endorsement given and received. So basically, like every chunk of data that LinkedIn has on me, we have here in these CSV files. So that's pretty cool. So that's the sort of in data lake side of just storing the raw data and storing the unpacked sort of staging data. One of the things that we can also do here is have different retention policies for different things. So I may want to keep keep each specific raw uploaded file. And you can see with this, I have when I uploaded it from my computer, I appended the date onto the export, so that this way I can just do another export and upload that with a new date and keep all of the raw data and just go unpack whichever one is the most recent. So that's one strategy for actually holding onto data in a sort of data lake format. So I then also have data in BigQuery. Haven't gotten it all in here yet, but the approximate hierarchy here is to go from raw data to cleaned data to modeled data. And here I've got currently 2 data sets in here. Haven't gotten the rest in yet, but we've got the Google form data for the weight tracking that I mentioned. So again, whenever I weigh myself, I put that data into a Google form, and that Google form goes into a Google Sheet, which I'm then referencing here as a external table. So I've got a view. Again, if this was something more robust that I wanted to be more maintainable, I would do this. I would define this view in dbt, but for a personal project, this is, I think, an appropriate level of rigor for now. And so you can see that I've got the cleaning part here, which is converting the timestamp into a proper date. And then for the model data, I've created a fact here of this, which is basically making normalizing on days. So there's at most 1 measurement per day. And that means that if I say weighed myself twice in one day, it's just going to take the higher weight. So in this case, with this sort of fact and dimension model, there's no way to cheat and try and step on the scale at the very end of the day to get a lower weight. So one of the very cool things in BigQuery is I can go ahead. Actually, let me do this properly. So we've got measurement date and daily weight. And BigQuery is going to say that yes, this compiles and will run. I'm going to go ahead and run that. And you can see that we've got results. And to get into the BI side of that, I can hit Explore Data and open it in Sheets, Looker Studio, or Google Colab. I'm going to do Looker Studio and pull this up. And it's going to auto-generate some charts for record counts, but we don't actually, we don't want these. I'm going to delete this one and then convert this one into a chart for time series. Now we're going to have to update this so that it's not aligned to 0. It's linear interpolation, and we're going to need to change the setup so that it is daily weight as the metric. So we're going to get rid of metric count, and this should give us a nice time series of my weight over the last couple of years since I started measuring this. And you can see that there are various cycles of gaining mass and then losing mass as I've sort of alternated between going to the gym and not going to the gym. So yeah, that is sort of this personal data warehouse stack in a sort of quick demo. There are a lot of places where it is not finished, but again, it's an iterative process. So with that said, let me go through my conclusion real quick, and then we can switch to full Q&A. So a couple of conclusions and caveats. So like I said at the beginning, modern data stack is to a large extent a marketing term and fad. Companies like DBT Labs and Fivetran, I think, are benefiting from being the key component of the modern data stack. So take all of this with a grain of salt. And whenever a vendor says that their tool is magic, assume that the magic is very contingent. Likewise, a lot of components of the modern data stack have sharp edges. Costs, it's very easy for costs to get out of control if you have too many people with too much access. And that is, again, sort of one of the upsides is that individual users are greatly empowered, but all of these tools charge accordingly. And so it's very easy to accidentally be spending a full engineer salary or several engineer salary on cloud spend when you really don't have to. Likewise, the tools are very, very powerful, which means that it's much easier to make updates to your pipelines, not necessarily more correct with your updates though. So it is, I think, easier to make any changes. And that means that you also increase the frequency at which you'll have incidents. And many of the tools don't integrate nicely with modern testing and CI/CD practices. So there are a lot of places where embracing the modern data stack actually limits the quality of which you can develop software around them. So there are places where you are making trade-offs, and those trade-offs have real costs. But I think in most cases, it's worth it to actually just get things up and running and start delivering value faster so that you can then choose to invest more in the process and tooling when it makes sense. And the third caveat is, modern data stack makes it sound like it's done. There's still a huge amount of room for improvement for specific tools. And I think we're going to see more sort of all-in-one platforms becoming increasingly competitive. Things like Databricks, and actually Google Cloud is in the process of sort of integrating most of their tools into a more cohesive platform that I think provides potentially a lot of value, because there's a lot of building different integrations between different best-in-breed providers and tools, and that's a huge amount of work to get that working nicely. Also, I think that sort of integrations, that sort of rebundling, there's a huge opportunity for that in just the metadata, and we've seen some of the recent huge data startups like Monte Carlo, the data observability space. That's super hot right now because a lot of that is just aggregating all of the metadata and trying to use that for better data management. So a lot of places where the modern data stack isn't done and there's room for improvement. So this is not the end for the evolution of data tools. And again, the best data stack is the one that works best for you. So this is systems design. So you want to develop a system that provides the capabilities you want, and usually in the simplest, fastest, and most cost-effective way possible. So actually, you gotta unfortunately have to think about this. I don't have rules of thumb that prevent you from having to think. But yeah, system design, it's iterative. So you'll never get it perfect, but oftentimes it's very feasible to get things to work well enough in a reasonable amount of time. And with that, I will take questions now. Thank you all for your time. And again, I'm actively looking for new data engineering or technical product manager roles. So if you are aware of any interesting opportunities, happy to chat further. All right, let's see what we have for questions. Ooh. So 2 questions. One is ELK. So Elasticsearch, Logstash, and Kibana. Raman has seen it mentioned on data platforms like Reddit. Is it not really necessary, or we're missing something? So I did mention ELK stack previously as part of systems of observability. ELK stack is really optimized for, or sort of originally designed for, dealing with logs and system monitoring. So I do know people who have used the ELK stack as their data platform, and in a sort of more modern sense where you're really thinking about everything as a series of events, that works surprisingly well. However, there are a lot of places where basically like logging and systems observability tools like ELK stack, like Prometheus and Grafana, Datadog, New Relic, all of those, they have slightly different intended data access patterns than a modern SQL-based data warehouse. And that means that you'll either end up with, well, usually you'll end up with both higher costs and additional complexities to actually get access to the data. So for like ELK stack, for example, you're not writing SQL, you're writing a specific domain-specific query language. So because it's not SQL based, that's an additional learning curve. And one of the big things that is a sort of a part of operating a modern data stack well is the data management and transformation side, in terms of going from raw data to cleaned data to well-modeled data that's easy to understand. And usually those steps don't happen for a systems observability standpoint. You'll have some of your SREs or developers or people build dashboards, and that's that. Ideally, you'll actually have better data for data analysts and data scientists, or for the applications that are going to be consuming data. So systems monitoring and observability tools are important for running any software system, but they're slightly different and have slightly different intended uses than what we're talking about with like data stacks in cloud data warehouses. Yeah. One thing I'll also say is I do know people who they take relevant compacted logs and actually will export them into their data lake and then data warehouse for more interesting events. But you also get, with logs, which are usually higher volume than other data, you'll usually end up with more aggressive retention policies where you'll actually want to rotate out your logs and delete them pretty quickly to avoid just filling up your cloud with junk data that you have to pay for. So cool. Another question that it looks like Rahul answered is, relative to each other, which has fallen more sharply? The cost of memory, RAM, or the cost of storage? Storage has fallen much, much, much more sharply than RAM. And actually RAM has gotten a lot cheaper as well. One of the limiting factors at this point is not RAM, but actual like CPU cache memory. So you've got a lot of places where the speed at which you can process data is limited to a single CPU core, often a single thread. and that's limited by how fast it can cycle data in and out of the different cache levels. So they're, L1 cache is still the most expensive memory in existence, pretty much. Ooh, another great question to close out on. When choosing the optimal combination of open source and paid services, which of the core components would each be useful? Ingestion versus transformation, et cetera. So the biggest component that I think you should not go open source on is the actual data warehouse. Again, the modern cloud data warehouses are incredibly cheap at small scales and would require a lot of overhead and sophisticated operations experience to actually replicate. I know Rahul has done, I don't know, dozens, if not hundreds of presentations on like Cassandra, and that's like a huge pain to actually stand up your own data warehouse or data warehouse equivalent. So that's the one that definitely I do not recommend trying to open source that, though at the same time, you can get surprisingly far using just Postgres or something like ClickHouse, where it's a analytics-oriented database. So there are lots of options there, and if you're skilled, I think they're good options. But for the actual key data store, the data warehouse, I would not recommend open sourcing that. So that's the primary thing that I recommend using a managed service for. The second one is in a typical business context, using a tool like Stitch or Fivetran for the managed ETL is incredibly valuable because they maintain all of the integrations. Whereas if you have to build your own integration, usually it's not too hard for most SaaS tools. If you want to go and send data to Google Ads, pull data from something, it's not too hard. But the thing that gets surprising there is the maintenance workload. So, if you want to say send conversion data to Google Ads instead of using a reverse ETL tool, it's not too hard, but they're going to change their API up every 6 to 18 months, and then you have to update that or things will break. So managed integrations save you the trouble of having to deal with integration updates most of the time. There are a lot of places where I think open source really makes sense is orchestration and transformation. So dbt core, awesome. Airflow, awesome. Those are great things to go for open source. Oh. So I think we're almost at the top of the hour.
Right, I think that's it in terms of questions. As we close out, if you do have any questions or any comments, please leave them in the chat. Just to close out, well, I want to thank you again for another excellent lunch. We really appreciate it. I'd like to thank everyone for joining us. I know we have a lot of people in different time zones, so as always, we appreciate it. I'd like to point you to our final run book, our current run book, the final hours for our current run book. Please download that if you haven't already. Check our events page. We have some great talks coming up. Hopefully we'll be able to get Will back for another fantastic talk, another encore. It was great. Just want to thank everybody for joining today. We'll see you guys same time, same place next week. Have a great afternoon, everyone. Take care.